Okay, let's continue. Let's continue. Um, just now we have talked about subnetting scams. Now we will turn to CIDR scams. What is the routing aggregation? What is the route aggregation? Aggregation means instead of splitting an address block into subnets, here we combine multiple small prefixes into a single larger prefix. This process is called route aggregation. Route aggregation. The resulting larger prefix is sometimes called a supernet, to contrast with subnets as division of blocks of addresses. With aggregation, IP addresses are combined in prefixes of various sizes. It is up to each router to have the corresponding prefix information. This design works with subnetting and is called CIDR, which is pronounced cider, as in the drink. The most recent version of it is specified in the document RFC, this one, 4632. To make the CIDR easier to understand, let us consider an example in which a block of 8,192 IP addresses is available, starting at this IP address, network address. Suppose that Cambridge University needs 2,000 addresses and is assigned the address. The base address is 194.24.0.0 through this .255, along with the mask 255.255.248.0. This is a /21 prefix. Next, Oxford University asks for 4,096 addresses, since a block of 4,000 addresses must lie on a 4,096 byte boundary. Oxford cannot be given address starting at .8.0. Instead, it gets this one along with the subset mask. So finally, the University Edinburgh asked for 1,000 addresses, signed this. So some confusing. So next time I have some questions about CIDR for you. So next time we will do some exercises about CIDR or subnetting. So today if you don't understand what the process of CIDR, it doesn't matter. Okay. CIDR means also the prefix, each prefixes for each university, but the backbone router can aggregate the prefix for these several subletting. Prefixes are allowed to overlap. The rule is that packets are sent in the direction of the most specific route or longest matching prefix that has the fewest IP addresses. Longest matching prefix or routing prefix provides a useful degree of flexibility, as seen in the behavior of router at New York in Fig 52. Fig 52. This router still use a single aggregate prefix to send traffic for the 3 universities to London. This is San Francisco, New York, London. This is aggregate router. Here is a comparison between class for addressing and the CIDR addressing. The IP address format listed here, and the IP addresses classed into 5 classes: A, B, C, D, and E. And class A set the 0 bit at the topmost bit. B set have 1 0, these 2 bits for the topmost 2 bits. C 110, D 1110, E 1111. The classic class A, B, and C formats allows for up to 128 networks with 60 million hosts each. 16,000 networks with up to 65,000 hosts each, and 2 million networks with up to 256 hosts each. Although a few of these are special. Also supported is multicast, the class D format, in which a datagram is directed to multiple hosts. Addresses beginning with 1111 are reserved for use in the future. This is that means class E is reserved for future use. They would be valuable to use now, given the ablation of IPv4 address space. Unfortunately, many hosts will not accept these addresses as valid because they have been off limits for so long. It's hard to teach old hosts new tricks. This is a hierarchical design, but unlike CIDR, the sizes of the address blocks are fixed. Over 2 billion addresses exist, but organizing the address space by classes with millions of them. In particular, the real volume is the class B network. For most organizations, a class A network with 16 million addresses is too big. And the class C network with 256 addresses is too small. A class B network with 65,000 is just right. In reality, the class B address is far too large for most organizations. Studies have shown that more than half of all class B networks have fewer than 50 hosts. A class C network would have done the job, but no doubt every organization that asks for a class B address thought that one day it would outgrow the 8-bit host field. Okay. Here, there are some special IP addresses. All zero means this host. Network portion with all 0 bit, and the host portion has specific the combination of 1 0. That means a host on this network. A host on this network. All 0 means broadcast on the local network. This network with all 1 bit means broadcast on the distant network. 127 then followed with anything means loopback address. So we should memorize that this special IP addresses, especially the 127. 127, for example, usually we can pin 127.0.0.1. Can find you can pin your local machine. Pin your local machine. This is pin your local machine. Usually successful. Patches sent to that addresses are not put out onto the wire. They are processed locally. Processed locally and treated as incoming packets. Okay. The problem of running out of IP addresses is not a theoretical. It's not a theoretical one that might occur at some point in the distant future. It is happening right here and right now. The long-term solution is for the whole internet to migrate to IPv6, the next generation of IP protocol, which has 128-bit addresses. This transition is slowly occurring, but it will be years before the process is complete. To get by in the meantime, a quick fix was needed. A quick fix. That means before the completely migrated to IPv6, a quick fix was needed. This quick fix, widely used today, that is the form of network address translation, which is described in RFC 3022, and which we will summarize below. The basic idea behind NAT is for ISP to assign each or business a single IP address for internet traffic. Within the customer network, every computer gets a unique IP address, which is used for routing intramural network. However, just before a packet exits the customer network and goes to ISP, an address translation from the unique internal IP address to the shared public IP address takes place. This translation makes use of 3 ranges of IP addresses that have been declared as private. Networks may use them internally as they wish. The only rule is that no packets containing these addresses may appear on the internet itself. The 3 blocks of private addresses listed here 10, 172, 192. This block about 16 million is 1 million, 65,000 hosts. It's very large. This figure 55, illustrate the shows the placement and operation of a NAT box, means NAT router. NAT router usually here. This is a NAT box or firewall. This laptop, PC or printer is in the local area network. Packets before translation have such private address with 10.0.0.1 with the port number 55 4. Then translate to the global valid address 198.60.42.12 to a new port. So there's some complex for net techniques. Next time, I will give you some examples of net. Okay, so much for today. Thank you. Bye. So much for today. Bye.